In my last video, I did COMC question B2. It is a very simple problem, and today I am going to do a much complicated question, which is COMC question B4. And don't forget to subscribe my channel. Let's get into the question now. So the question is, Bob and Jane hold identical decks of 12 cards, 3 of each color, red, green, yellow, and blue. Bob and Jane shuffle their decks and then takes turn dealing one card at a time onto a pile, with Jane going first. Find the probability that Jane deals all her red cards before Bob deals any of his red cards. Give your answer in the form of fraction in lowest terms. So we know that probability equals the number of ways it can happen divided by the total number of outcomes. Next, we'll be finding these two values. And first, we'll be finding out what total number of outcome is. So Jane has 12 choose 3 times 9 choose 3 times 6 choose 3 times 3 choose 3 ways to have her deck. And Bob also has this many ways to have his deck. And let x to be 9 choose 3 times 6 choose 3 times 3 choose 3. And x is also the number of ways to place green, yellow, and blue in 9 spots. And so the total number of outcome is 12 choose 3 times 9 choose 3 times 6 choose 3 times 3 choose 3 to the square, and that equals 12 choose 3 squared times x squared. And next we'll be finding the number of ways that it can happen. So case 1. Jane deals all her red cards in the first 3 cards that she put down, and Bob deals none of his red cards in his first 2 cards. So Jane must put 3 red cards in the top 3 cards of her pile. And there is only one way to do that. And once all 3 cards are placed, and there will be x ways to place the remainder. And Bob must put 3 cards at the bottom 10 card of his pile. So there will be 10 choose 3 ways to do that. And once 3 cards are placed, and there will be x ways to place the remainder. So in total, there are 10 choose 3 times x squared ways to place in this case. And now case 2. So Jane deals all her red cards in the first 4 cards she put down, and Bob deals none of his red cards in the first 3 cards. Jane must put 3 of her red cards in the top 4 cards of her pile. But if the 4th card is not red, then it will become case 1. And so the 4th card must be red. And once this red is placed, there will be 3 choose 2 ways to place other 2 red. And so there will be 3 choose 2 ways to place her red cards. And once all red cards are placed, there will be x ways to place the remainder. And Bob must put 3 of her red cards in the bottom 9 of his pile. And there will be 9 choose 3 ways to do that. And once these 3 red cards are placed, there will be x ways to place the remainder. And so in total, there are 3 choose 2 times 9 choose 3 times x squared ways to place in this case. Now, let's get into case 3. So Jane deals all her red cards in the first 5 cards that she put down, and Bob deals none of his red cards in the first 4 cards. And Jane must put 3 cards in the top 5 cards of her pile. And once again, if the 5th card is not red, then it will become either case 1 or case 2. Then it's not case 3. And so the 5th card must be red. And once this red is placed, there will be 4 choose 2 ways to place other 2 red. And so there will be 4 choose 2 ways to place the red. And once all 3 red are placed, there will be x ways to place the remainder. And Bob must put 3 of his red cards in the bottom 8 of his pile. So there are 8 choose 3 ways to do that. And once all 3 red are placed, there will be x ways to place the remainder. And in total, there are 4 choose 2 times 8 choose 3 times x squared ways to place in this case. And I don't have to go through all of the cases because we can already see a pattern here. And so there are 10 choose 3 times x squared ways to place card in case 1. And there are 3 choose 2 times 9 choose 3 times x squared ways to place card in case 2. And there are 4 choose 2 times 8 choose 3 times x squared ways to place card in case 3. And I expect you to see the pattern here. So there are 10 choose 3 times x squared, and it is also 2 choose 2 times 10 choose 3 times x squared ways to place card in case 1. And there are 3 choose 2 times 9 choose 3 times x squared ways to place card in case 2. And there are 4 choose 2 times 8 choose 3 times x squared ways to place card in case 3. And following the pattern, there will be 5 choose 2 times 7 choose 3 times x squared ways to place card in case 4. And there will be 6 choose 2 times 6 choose 3 times x squared ways to place card in case 5. And blah blah blah. Until there will be 9 choose 2 times 3 choose 3 times x squared ways to place card in case 8. Now, we don't need to go any further because in case 9 there will be 10 choose 2 times 2 choose 3 times x squared ways, and it's 2 choose 3, and there is no way to choose 3 in 2 things. So in total, there are x squared times sigma I equals 2 to 9. I choose 2 times 12 minus I choose 3 ways to place cards. And now, let's calculate this complicated expression. So this expression is equal to x squared times sigma I equals 2 to 9. I choose 2 times 12 minus I choose 3 plus x squared times 1 choose 2 times 11 choose 3 plus x squared times 10 choose 2 times 2 choose 3 plus x squared times 11 choose 2 times 1 choose 3 plus x squared times 12 choose 2 times 0 choose 3. That's because 1 choose 2 and 2 choose 3 and 1 choose 3 and 0 choose 3 are all equal to 0. And this equals to x squared times sigma I equals 1 to 12. I choose 2 times 12 minus I choose 3. That equals to x squared times 13 choose 6. And is also equal to x squared times 11 times 12 times 13. In total, there are x squared times 11 times 12 times 13 ways to place cards. We know that the probability equals to the number of ways it can happen divided by the total number of outcomes. And we know that the total number of outcomes is 12 choose 3 to the square times x squared. And we also know that the number of ways it can happen is x squared times 11 times 12 times 13. And so the probability equals to x squared times 11 times 12 times 13 over 12 choose 3 squared times x squared. And that equals to 11 times 12 times 13 over 12 choose 3 squared. And that equals to 11 times 12 times 13 over 12 times 11 times 10 over 3 times 2 times 1 squared. And that equals to 11 times 12 times 13 over 2 times 11 times 10 squared. And that equals to 3 times 13 over 11 times 10 squared. And it equals to 39 over 1100. And so we get our answer. And our answer is 39 over 1100. In this question, they're testing about your skill of casework and simple combinatorics. And if you like my video, Make sure to subscribe my channel and don't hesitate to leave a comment if you have any questions. In my next video, I'll be talking about the COMC 2019 question C1.